Hello, I welcome you all for my mathematics class. I am continuing with the probability theory. So you see that I am continuing with the probability theory. I have taken 2 classes on this, wherein I have discussed the basics of probability. What is a probability? What is addition theorem? What is multiplication theorem? That is conditional probability. And also I have discussed in length some of the problems. And today I will be continuing this for some days, because probability is a very big topic that even if I take for 20 or 25 classes, still there will be more and more to be taught. So I will continue till a stage where I feel that no more is required. So it may be like that. So you see that, let me do this now. So today I will take up another problem which is important, which will give a broader idea for the students to approach the problems. That is, I should teach you in such a way that you must learn from my teaching and see that you become an independent thinker. You start thinking or activate, that is, kindle your brain to solve the problems independently. So I should bring you to that stage, or make you feel that you gain the confidence to do the problem. So that is my idea of taking class. Okay, that's why you see that I do the problems on the board, just like that, teaching you as in a classroom. Okay, now you see that today I will take up a problem. See, there are 2 urns in the sense it is nothing but, see, there are 2 urns. There are 2 urns, say A and B. See, A contains 5 white and 3 black balls. See, A contains 5 white and 3 black balls. B contains 3 white and 5 black balls. See, 2 balls. See, one ball is drawn from A and B. One ball is drawn from A and B, and one ball is drawn, 2 balls, I see here 2 balls. 2 balls are drawn. 2 balls are drawn, I will put it in this way. 2 balls are drawn from A and placed in B. Then one ball is taken out from B. What is the probability that it is white? So this is what is the problem. So you see that I'll read this problem. This is the problem that I am going to discuss today. There are 2 urns. There are 2 urns. Urns means they are just like your vessels. They are nothing more than that. So containers. There are there are two urns A and B, and A contains 5 white and 3 black balls. B contains 3 white and 5 black balls. 2 balls are drawn from A and placed in B, and then 1 ball is taken out from B. Question is, what is the probability that it is white? So it is as simple as that. Now let me start doing the problem. You see that here you have got this is your A, and you see that here you have got 5 white and black balls, see, and these are 8 balls, and here you have got your B, and here 3 white balls, 5 black balls, 8. So you see that now when you have to draw 2 balls from this, place in this and pull 1 out, so that will be your white ball. Okay, now let us start doing this. Now you see that when you pull 2 balls out from this A, it can be, there are 2 possibilities. That means I will put it like this. See, A, you pull 2 balls out. So you see that here it can be 2 black balls or 2 white balls or 1 black, 1 white. And then you just drop this in. See, if this goes, see, this can fall in this. See, so you see that you see that A, from A you take, pictorially I will explain how this is happening. So this urn A is here, and you take 2 balls out. The possibility is 2 black balls or 2 white balls or 1 white ball. When this comes here, you see that, so what is the probability that you get 2 white balls, 2 black balls? What is the probability? I can explain with this diagram itself. So after then I will tell you how it should be worded and properly put as a answer for the problem. Okay, now you see that probability of 2 black balls. Now you see that here you have got 5 white balls and 3 black balls. So you see that you want 3 black balls, means it is 3C2 divided by 8C2. So this will be equal to your, so you see that this will be equal to your 3 into 2 divided by 8 into 7, that is equal to, you will get it as 3 by 28. I will keep it as 3 by 28. Now you see that, come to this. So when this 2 white balls you take, here you see that probability of 2 white balls will be equal to, here 5 white balls are there, so it is 5C2 divided by 8C2, that is equal to 5 into 4 divided by 8 into 7. So this will go to 10 by 28. So you come to this will be your probability. Here you see that probability of 1 black, 1 white is equal to, see, what is the probability of taking 1 white? It is 5C1 into 3C1 divided by 8C2. So this is 5 into 3 divided by 8 into 7, that is equal to, you will get this to be, here it is 5 into divided by 1 into 2. So 1 into 2, that is 5 into 3 into 2 divided by 8 into 7, that is equal to 15 by 28. So you see that, if you want, I can just continue doing like this. That means I will write here probability of, see, probability of 2B is equal to your 3 by 28, and probability of 2W is equal to your 10 by 28, and probability of 1B, 1W, 1B, 1W is equal to 15 by 28. So you see that, So you see that this will come and fall. So you see that, so in this way you see that this will come and fall in this particular. After then, what is that you take? You take one ball, and that one ball must be white. Can you understand? Now you have to find what is the probability of that. So that is very simple understanding of this. Now you see that coming to this, I will put it in this way. So this is with regard to this. So I will erase this. Now you see that these three will come and fall in this B. So here you see that here you have got this B. Here I will put it like this here. Here you have got here B. So you see that B has got two formations like this. See, first one is this 3 by 28. That means two balls. Here you see that it will get to here. How many balls are here? 3 white, 5 black balls. So equal to 8. There are 8 balls. So when these two balls come and fall in this, you see that there will be 7 balls. 7 plus 3 will be 10. So you see that here if two balls come, two black balls come here. If two black balls come, so you see that what will happen is it will be 3 plus 7. So this is equal to 10. So you see that here I will put it in this way. So here you see that if two balls, this is your two balls come here. So 2 black balls plus 5 black balls, 7 black balls, and you get already 3 white. So you see that 10 balls. So you see that in this, if two balls come and fall here, 10 balls. Now what is the probability of taking one white? Now this is the question. Now what is the probability of taking one white? See, you see that you must understand one aspect here. Here my idea is to, I am concentrating on finding one white. See, let me call that drawing white as an event A. I don't put it as one white. I will call that as an event A. That means A is an event. I'll write everything here. So A is the event of drawing one white ball. Okay. Now you see that this A, see here you see that this taking white ball, one white ball, it is varying from conditions to conditions. Here you see that when two black balls come here, it is changing. That means what, previously it was 3 white and 5 black balls. There removing a white ball is different. That is different. But when these two balls come and fall here, you see that the number of ball has increased to 10, and that the number of balls in black and white also change. Can you understand? In which case, the drawing the white ball, it is depending on the fall of the ball, or the black or the white, or the combination of these two that are placed in B after removing from A. Are you able to understand? I'll repeat this again because this is something important that you must follow. You see that here it is very plain. Here there are 3 chances, either 2 black balls or 2 white balls or 1 black and 1 white. Here the probability of removing 2 black balls is 3 by 28, and the probability of drawing 2 white balls is 10 by 28, and the drawing 1 white and 1 black I have got here. Now you just see that here if you talk as such, if you take B as such, you see that it is as plain as that. Drawing a 1 white ball means you can very well do. It's very, very simple, straightforward. You apply probability that is then the number of favorites divided by number of the exhaustive. So you apply that, you will get classical definition. But you see that there is a change taking place. There is a change of probability takes place because of placing the the balls drawn from A. So in the first case it is 2B, in the second case it is 2W, in the third case it is 1B and 1W. Therefore I should say that here this A, see here you see that A, here I will put it here. This A is, see I'll write here, A drawing one white. A is the event of drawing one white ball. So you see that you can draw. So the drawing of white ball takes after what happens only when this is done. That means, let me, if you want, I can call this as, you see, this is, if you want, I will put it in this. See, you take A. See, this A comes, so you can, probability of this given the probability of this. That means what? After drawing 2B. I will first explain this and give you. Now you read this. The conditional probability of A slash, conditional probability of A slash 2B means here two black balls come. See, two black balls come. Here you see that two white. Yes, it is two black balls come and you take A. A is the what? A is the drawing a one white ball. So you see that, so this will be nothing but, I will write here, this will be nothing but, you see that here how many balls have come? 10. And how many white balls are here? You see that A is drawing a white ball. So how many white balls are there? Here still it remains as 3 white balls. So it is nothing but 3C1 divided by 10C1, that is equal to 3 by 10. So you see that here the probability of drawing one white ball is 3 by 10. Now those who are watching this definitely can understand better. Now they will be in a position to say what should I do in the middle one. See, what is this middle one here? This middle one is nothing but this 2W coming. See, when 2W comes, it changes as what? 5W plus 5 black. So you see that again it remains as 10. So this is 10. Now you see that here your probability of drawing A when what? 2W comes. Can you understand? So 2W comes. So 2W comes. So this is equal to how many? Now you see that it is completely changing. How many white balls are there? 5. So it is 5C1 divided by 10C1, that is equal to what? It is 5, it is 2, it is coming here, so 3 plus 2 is 5, so 5 by 10. So you see that 5C1 divided by 10C1. So you see that, so this is one. And now let us come to the third one. Now when it comes over here, it will be nothing but what? 4W plus 6 black balls, that is again 10 balls. Now probability of drawing A, given that how many balls have come here? 1 black ball, 1 white ball is equal to, see here there are 4, so it is 4C1 by 10C1, that is equal to this. So you see that, see otherwise if I ask you plainly, without this happening, if I ask you it is 3 by 8, it will be 3 by 8 is the drawing 3C1 divided by 8C1, that is the answer. But it has become a conditional probability because you are dropping something. So the changes, here when you drop 2 black balls it is different. See, it is 3 by 10. When you drop 2 white balls it is 5 by 10. Well, so when you drop 1 white, so it is completely changing. You see that? Therefore, here drawing a white ball, it is, say, the conditional probability of A, which is drawing 1 white ball, given that your probability of this has come, that is 2B, 2W and 1B, 1W. So this is the idea. Now you see that, now what is that you want now? So I will rub off this. So now what is the probability of drawing A? So what is that you want? So here everything is common. This is comes because see it is a probability. See, it is total probability. See, this P is your total probability. This P is given by P of A. A, that means what? What I want to tell you is that if you have a, see for example, let me, you have got only 3 here, so it is like this. 1, 2. Let me take this as A, take this as B, and take this as C, and you take this as D, which is common. So you see that this D, A, B, C are three events and they are mutually disjoint. Try to understand. A, B, C are mutually disjoint and D is common event for A, B, C. So D is a common. It is a common event. What? Which is common to what? That means what? It is an event which is intersecting A, B and C. A, B and C. And therefore you see that A intersection B. You must very well understand that. Here you see that three events are there. A, B, C are three events, and that D is an event which is common to all, and therefore the probability of D, which is called the total probability, it is given by, you see that P of D slash A into P of A plus P of D slash B, conditional probability here, into P of B plus P of D slash C into P of C. So this is called your total probability. So this is called your total. So if there are three events A, B, C and D is an event which is common to A, B and C, then the total probability is P of A, which is given by this P of D slash A into P of A. This is nothing but the conditional probability of A given D, and that is of D given A, conditional probability of D given B, and same as this, and P of everything all. Now probabilities will be known to you, the values of all these will be known to you, so that PA can be calculated. Now let me call this, see, you call this, see, I'll write it here, let X be the event of drawing two black balls from A. Let Y be the event of drawing two white balls from A. Let Z be the drawing one black ball, one white ball from A. Then P of X is equal to 3 by 28. P of Y is equal to 10 by 28. P of Z is equal to 15 by 28. So you see that this is what you get. So if you call this 2B as the event of drawing two black balls, so it is P of X, P of Y, P of Z. Now you see that, therefore I will write everything here. I have given you this, so let me start writing this. So therefore I will rub off this, so I have got this. Therefore see, if when the balls are placed in B and one ball is drawn from B and it happens to be white, then see, you see that P of, see, what will you write in this? A slash X, see, A slash X is equal to, yes. So what is your a slash x? A slash x will be equal to 3 by 10. P of a slash y means here conditional probability. A slash y is equal to 5 by 10. P of a slash z is equal to your this one 3 by 10, 5 by 10 and 15 by here not 4 by 10. See, this is 3 by 10, 5 by 10, 4 by 10. So you see that I am able to, so coming from, let x be the event of drawing 2 black balls from A, 2 white balls from A, 1 black ball and 1 white ball. Then you see that I have explained everything here. P of x is equal to 3 by 28, P of y is equal to 10 by 28 and P of z is equal to 15 by 28. See, when these are transferred to B, the probability of taking white balls naturally change from one way to another. This is one way, this is another way, this is another way. If this is done, this is what you get. If this is done here, you see that 10 by 28 means 5 by 10. 15 by 28, if you have, that is 2 white balls. Here you see that 1 white ball and 1 black ball dropped means you are getting a different probability. So you see that when this is so, you see that we are getting this P of z. Now what is that you want here? We want the total probability. Now you see that here, you just see that here, this is, that is here in this, see whether this is dropped or whether this is dropped or this is dropped. In all the 3 cases, you see that you want a white ball, correct or not? Am I correct or not? See, whether you drop 2 black balls or 2 white balls or 1 white ball and 1 black ball, in all the 3 cases what is wanted is probability of A. That means it is the total probability. Are you able to catch what I am telling you? So you see that this A drawing probability, the probability of drawing A has now become a total probability, for the simple reason whether you take 2 black balls and drop in, or whether 2 white balls you drop and take 1 white ball and 1 black ball and drop in B and then pull one out, you see that you want it to be a black ball. So you see that there are 3 events. Say taking 2 white balls, see, let me put it in this way. If you want here, I will put it in this way. So this is your x, this is your y, this is your z and this is your A. Now you just see how well you understand this. So x is taking 2 black balls, y is taking 2 white balls, and this is, no, you drop and then you see that what is that you want to take? The common thing is the white ball A. So you are going to take, so that white A is common to everything. Now you see that I am going to use this total probability. So you see this total probability is given by this. So what is that you get here? So P of A is the total probability. So this P of A, therefore here P of A is equal to P of A slash x into P of x plus P of A slash y into P of y plus P of A slash z into P of z. So can you see this? They are very so it is, I am able to make you how well you can compare the total probability of the given problem with the theory. Can you understand? See, this is the understanding I gave you. Now I am explaining how you can view this as a total probability. Are you able to understand? So this is your total probability. Now you just substitute the values, you will get the answer. What is your A slash x? What is your A slash x? See, here you have got A slash x. So this is equal to 3 by 10 into what is your P of x? 3 by 28. See, this is plus, what is this? P of 5 by 10 into P of 10 by 28 plus It is, what is your P of A slash Z? Where is your P of A slash Z? 4 by 10 into 15 by 28. So you see that this you get it as 9 by 280 plus 50 by 280 plus 60 by 280. That is equal to, you get what? This is 119 by 280. So this is what you get. That is the probability of from yes, A I have here, this A I will put it as no A dash. If you want you can just name, because A I have already taken, so this you can call this earn A, see UA, you can call this UA, UB, earn B. So this is your earn means the vessel. This is earn A and this is earn B, and you see that here this A refers to, see I mean A is drawing one ball, white ball out. Here UA means earn A, it is the vessel. This is earn B, so do not confuse with that. So you see that the probability of drawing one white ball from B after drawing balls from A and placing in B is equal to 119 by 280. So this is the probability of this. I hope that I have explained each and every step. How do you get and what is the reason that you do. I have given actually a diagrammatical representation of all this so that you can understand. So here you see that 2B means this much, 2W means this, 1W, 1B means this. You are going to drop in this. When you drop, completely the system changes. So it becomes 10 balls it gets, 3 balls and 5, so it is 3 and 7 black balls, or it becomes 5 white and 5 black balls, or it becomes 4 white and, because the effect comes because of you drop the balls in this one. So because of that, so this can, see this 3 by 10 can come only because of what? Dropping 2 black balls, and this 5 by 10 comes only because of what? Dropping 2 white balls, and this comes only because of what? 1 white and 1 black. If this is so, then you are going to take one white ball out. That white ball is nothing but common to these 3 are there, these 3 are here, and for this the common is white ball, and therefore we are finding the total probability, and this is how we get. So this is all about this problem. This is a quite a interesting problem, and you can practice, and just know that whatever I do, I put it in such a way that it enhances your understanding, enhances your knowledge, so that you become independent in approaching the problems and solve any problem. Okay, so with this let me go to the next small problem here. So this is a, see, I will do this. So this is I will do more problems, and you can the only thing is you have to attend all the classes and practice problems so that you will become good in that. So I'll take another problem. Let A, B, C, B pairwise independent events. And A and B union C are, they are independent. if A, B, C are pairwise independent events, A and B union C are independent events, prove that, prove that A, B, C are now. See, proof. Let me give you this. Very straightforward. You can very well do. See, A, B. See, what is that you want to prove this? You want to prove that proof. See, proof. See, given A, B, C are pairwise independent. That means P of AB is equal to P of A, P of B. AB means A intersection B, and P of BC is equal to P of B into P of C. P of C A is equal to P of C into P of A, and P of A intersection B union C is equal to P of A intersection P of B union C. So these are given. To prove A of P of A intersection B intersection C is equal to P of A, P of B, P of C. So this is what you should prove. Now, so having all these things, you can very well see what I will do here is. So this is given and this is given and this is what you should do. Prove. Now, P of, I will write here, P of A intersection B union C is equal to, so this I will write it as P of A intersection B union A intersection B union A intersection C. So you see that it is A intersection B. This is associative law. I am using associative law. A intersection B union A intersection C. Now you see that I do not know whether A intersection B and A intersection C are independent. I do not know that. But I will use what is called my addition theorem. Here you see that commutative law. And this is equal to, P of A intersection B plus P of A intersection C minus P of A intersection B intersection A intersection C. So this is what I get. So you see that this is nothing but, say I will write it here, this is addition theorem. What is addition theorem of probability? P of A union B is equal to P of A plus P of B minus P of A intersection B, provided A and B are not disjoint. Okay, they are not disjoint. So this is what I get. So you see that this is nothing. Now A and B are mutually this one. See P of A union B, A intersection B. See P of A intersection B is this. So you call this one. So this is P of A, P of B plus P of A into P of C minus, say this is all our intersection. A intersection B, intersection A intersection. See, idempotent law, everything holds good. A intersection B, see, it will be like this. See, what is this? A intersection B, commutative law holds good, everything holds good. So because of this, I will write it here, P of A intersection B intersection C. You know how does it come? See, this is A intersection B intersection. See, open this bracket because you see that this is associative law holds good. So you just simply add you open this bracket and you write it as A intersection B intersection A intersection C. But B intersection A is equal to A intersection B, because that is commutative law holds good in the case of intersection, that is conjunction. So you see that now it becomes A conjunction A is A conjunction A is A intersection A is A idempotent law. B, then you get A intersection B intersection C. You call this as your 1. Call this as your 2. Call this as your 2. Now then P of A intersection B union C. But A and these two are what? They are independent. So you will write this as P of A into P of B union C. But B union C is equal to P of A into P of B plus P of C minus P of B intersection C. So it's because I use here addition theorem here. So this is equal to P of A into P of B plus P of C minus P of B into P of C. Because you see that here I am using this 1, use 1. Using 1. So you see that because of that I am getting this result. Now you call this. So you see that this is also P of A intersection B union C. This is also same thing. Can you understand? These two are same quantity. For this is the result that I am getting. For this I am getting a different result here. Can you understand? So this is nothing but you take this P of A inside. So this is P of A into P of B plus P of A into P of C minus P of A, P of B into P of Z, P of C. Call this as your 3. Now you see that from 1 and 2, what is that you get here now? So you see that 2 and 1, you have got here 2 and 3. See, this is your 2 and this is your 3. This is, say, P of A intersection B union C is equal to so much. Same quantity is equal to so much. So 2 and 3 are equals. From 2 and 3, see these two, P of A, P of C, P of A, P of B, P of A, P of B, plus P of A into P of C minus P of A intersection B intersection C is equal to this one, P of A, P of A into P of B plus P of A into P of C minus P of A into P of B into P of C. So you see that P of A and P of B on left hand side and right hand side, they will get cancelled. And understand that they are all merely numbers. Whatever be the numbers, you see that it will be less than, it will be greater than 0, greater than or equal to 0, or less than or equal to 1. They are only merely numbers, you can very well cancel. So this and this will get, because they are both equal quantity. So here you see that both sides you have got minus, so make it as throughout multiply by minus. So this gives P of A intersection B intersection C is equal to P of A into P of B into C. This implies A comma B C are So these are the two problems that I wanted to discuss, and I have discussed in length. I will do distributions and other more interesting problems to come in my future classes. So we'll see the rest in the next class. Thank you.